Okay, we're now going to look at ways of measuring spread of a set of numbers. The spread is how the numbers are all spread out. So if you have a lot of numbers that are all similar to each other, you would have a low spread. And if you have numbers that are very diverse, very different from one another, then you'd have a higher value of the spread. We have three ways of measuring the spread. There are more than that, in fact. But the three ways we're going to look at are the range, the interquartile range, and the standard deviation. The range is simply how spread out they are from the extremes. It's the highest minus the lowest number. The interquartile range, is the same as that, except it's only looking at the middle half of the data. So we're ignoring the top quarter and ignoring the bottom quarter. The standard deviation is sort of like finding the average difference from each data point to the average of all data points. However, if you just found the average, just found the mean, it would be 0 because half the values would be above, half the values would be below. Well, maybe not half, but then once you actually take into account their values, then on average it would always be 0, no matter how spread out they were or not. So the way we get around that is we make everything positive. So we square the distance between each number and the mean. We divide that by the number of numbers and we take the square root. So it's a root mean squared measure. Okay, so let's start with the range. So this is the simplest way of measuring spread. Let's look at these numbers 1, 1, 2, 3, 5, 8, 13. And the range is the highest number minus the lowest number. This number minus that one is 13 minus 1. The range is 12. You go through 12 steps to get from the lowest number to the highest number. The interquartile range. The quartiles are three numbers that divide the data into 4 equal parts. Okay, so my interquartile range here, I've got 1, 2, 3, 4, 5, 6, 7 numbers. So that's my center number. And these are my quartiles. So you notice about the numbers I circled, I've got the same number of numbers between each of the circles. You see that? And the distance between them, this is an 8, that's a 1. 8 minus 1 is 7. That's my interquartile range. So you take the range of the middle half. You get rid of the top half and you get rid of the bottom half. Now with a small set of numbers, you're going to notice that the pieces you partition off aren't exactly half. I'll do a larger set of numbers, hopefully to make this idea a little more clear. Okay, so I've got a larger set of numbers here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So the very center of my data would be halfway between the 8th and the 9th number. So this is the middle here, which means my middle number is actually shared between two numbers. Now, if you watched the central tendency video, you'll see that to find the median, when you have two numbers, you take the average of them. So I want the average of 21 and 25. And 25 plus 21 is 46, and half of that is 23. So how did I get 23? I took 21 plus 25 and divided by 2. That gave me 46 divided by 2, that's 23. If you have an odd number of numbers, you just circle the middle number. But if you have an even number of numbers, you circle the two middle numbers, you find the average between them. That gives you your median. It also gives you your center quartile, Q2. Okay, so I've got 23. Now I've got this many numbers in the first half, and I'm going to find the middle of that. I've got 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Because there's 2 numbers in the middle, I include the endpoint. I've got 8 numbers. I'm going to grab the center of that. So 1, 2, 3, 4. I'm going to take this number here. It's actually in between those 2 numbers. It's a 4. That's called the first quartile. That's the second quartile. And in my top half, I've got these 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to grab the number that's here. That splits these 4 numbers from those 4 numbers. And the number I'm interested in is the average from 31 to 32. It is 31.5. We call that the Q3 point, the third quartile. The interquartile range is the top minus the bottom of this middle half. You see, imagine this set of numbers is broken into quarters. That's the first quarter, that's the second quarter, that's the third quarter, and that's the fourth quarter. The interquartile range is just the range, the distance, from the top to the bottom of the middle half. We get rid of the top quarter, we get rid of the bottom quarter, and look at the range of what's left over. That's interquartile range. So in this case, my interquartile range is 31.5 minus 4. So it is 27.5. And finally, we're going to look at the standard deviation. Now we're going to look at the population standard deviation as opposed to the sample standard deviation. The sample standard deviation, which your calculator readily finds, has a lower denominator, which gives a boost because if you take a sample of a set of numbers, it's going to be more likely clustered towards its own mean than the actual data is clustered around its true mean. So the standard deviation is what you get when you take the square root of the sum. This is the Greek capital sigma, it means sum. That's actually the lowercase sigma for standard deviation. And what we're going to add up is all of our data points. That's xi, just means one at a time. We're looking at each of the numbers in our list of numbers, minus the mean, and that's a Greek letter mu, it just stands for the mean, divided by n, which is the number of numbers. So we're going to add up the difference of each of the numbers with the mean, square them, and when we square them, it makes everything positive. Because you see, half the time this number will come out negative. Then we divide by the number of numbers, then we take the square root, and that's our measure of spread. So I'm going to use a small set of numbers so I can calculate this by hand, and you can see how it's done. Then I'll show you quickly how to do this on a calculator. Okay, so let me just use these numbers here. This is my data set, 1, 2, 3, 4, 5, same as an idiot would have on his luggage. And I'm going to find the mean, and the mean here is 3. You see 5 plus 4 is 9, 12, 14, 15, and 15 divided by 5 is 3. So the mean, which is denoted by this symbol here, is equal to 3. So my standard deviation is the square root of the sum. It's what I get when I add the difference of each of these numbers from the mean, square them, and divide by the number of numbers. So along the top of my fraction, I'm going to have 1 minus 3 squared plus 2 minus 3 . So I'm adding up the squares. I'm always doing a minus 3 because 3 is the mean. I'm always subtracting the mean from each of the numbers. I'm squaring what I get after I subtract, and then we're adding them together. And I'm going to divide by the number of numbers. So I'm going to divide by 5. So again, let's make this formula clear. That sigma, capital sigma, means sum, and sum means add. We're adding up. See, I'm adding up the difference, and the difference is what you get when you subtract each of the numbers from my list of numbers, the 1, the 2, the 3, the 4, and the 5. I'm adding up each of those after I subtract the mean. See, the mean is 3, and I'm subtracting 3 from each of them. And after I subtract, I'm squaring them. If you don't square them, half of them will be negative, half of them will be positive, and worse than that, they'll cancel each other out, and you'll always end up with 0. So we're going to square them, and then to undo that, we're square rooting the whole thing. So 1 minus 3 is negative 2. Negative 1 squared, 0 squared, 1 squared, and 2 squared. I'm using brackets when it comes out negative to remind me that when I'm squaring a negative which will turn it positive. We don't need the brackets here. There's no point because it's just we're applying that exponent 2 directly to it. So to see where these came from, 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. And all of that's divided by 5. 4 plus 1 is 5, plus 5 is 10. So that's 10 divided by 5, which is 2. So I want the square root of 2, and the square root of 2 is about 1.4. And let me just find it exactly. Square root of 2 is 1.41. So 1.41 is the standard deviation of this set of numbers. We can interpret that as it's sort of like the average distance that each of those numbers is from their own average. It's not exactly the average distance because we're square rooting the denominator as well as the numerator after squaring them. But it gives us a good representation of how spread out the data is. I'm just going to show you on this particular calculator how to get your calculator to show you the standard deviation, so you don't have to do this by hand when you have a larger set of numbers. So I'm going to put this into stat mode, and then I'm going to enter the numbers. So my numbers are 1, 2, 3, 4, and 5. And then for the standard deviation, I'm just going to find the standard deviation button. It's here. And when I press that, it gives me the 1.41 that I got by calculating this by hand. Now, On each calculator, they have sort of a different way of doing that. You're going to have to look that up in the manual, but quite typically, the M plus button is for recording the numbers that you enter, so you can enter each of these numbers and it'll remember all of them. And then the symbol you're looking for the standard deviation is one that looks like this. And so on this particular calculator, I had to press alpha to get it. That's like the green buttons, and then that gave me the standard deviation right there.